So the horizontal line test is a graphical way to tell whether or not the graph of a given function is one-to-one. So the horizontal line test says if a horizontal line crosses the graph of a function at more than one point, then that function is not one-to-one. In other words, it can't reach the same height value more than once, because then it would have the same output value more than once, because outputs are height values. So let's go back to some of the pictures we had at the beginning. If you have a line that goes like this or like this, doesn't really matter. It can't be a vertical line, because a vertical line is not a function in the first place, is it? A vertical line doesn't pass the vertical line test. But any other line with the equation y equals mx plus b, it's going to be a function because it passes the vertical line test, but furthermore, it's going to be a one-to-one function because it passes the horizontal line test. And the way you could show that is just, you can't draw every horizontal line, but just indicate, yeah, by inspection, you can tell that any horizontal line is only going to pass through at most one point. Same thing with that picture. If you're given the graph of a function and it passes the horizontal line test, in other words, any horizontal line goes through at most one point, then it's one-to-one. So you draw the horizontal line, you could draw it through both functions, both graphs, and I'm kind of doing two problems in one here. But if it passes the horizontal line test, then you could say that it's one-to-one by the horizontal line test. Let's use HLT for short, okay? But if you get a graph like a parabola, is that going to be one-to-one? Nah. And all you need is one horizontal line to show that it's not one-to-one, kind of like I did earlier. That horizontal line goes through two different points. Therefore, by the horizontal line test, it's not one-to-one. Not one-to-one by HLT.